Hi guys, this is going to be the last video for the 2018 FRQ Non-Calculator session. And let's see what this one does. So determine the concavity. So whenever it says concavity, that's going to be the second derivative of the curve from here to here. And find the reason for this. So it's very simple. We already know dy dx is already given to us. Like if you come back here, we already got here 2 minus. It's going to be 2 minus sine y, right? And we have to, wait, did we do the second derivative? No, we did not quite do the second derivative here. So yeah, we have to drive it one more time. So we have to do y double prime. So you already know it's going to be the quotient rule since it's a fraction. So let me put first one is the f, second one is the g. So you remember this one, right? It's gonna be f prime times g minus g prime times f over g squared. So we gotta find everything. F is equal to 2. I'm just referring this one from here. Therefore, f prime is equal to 0 because it's nothing but constant. G is equal to 2 minus sine y. And y prime is gonna be negative cosine of y times dy dx. All right, and we already know what dy dx is, so it's gonna be same thing as cosine of y times, because do you see dy dx is same thing as this, 2 minus sine y. Okay, I think that's what I really have to do here, but I don't know which one I'm gonna use. Maybe I will use this one first. Okay, so let's do this. So let's use this one from here. So f prime, which is going to be 0 times g, like 2 minus sine y, but I'm not sure if it really matters because that's going to go into 0, minus g prime, which is negative cosine of y. Let me put dy dx times dy dx over g squared. So g is a 2 minus sine y squared, right? So let's do this. These two disappear. Negative times negative become positive. So this is same thing as a cosine of y times dy. Now let me put this one in. 2 over 2 minus sine y over 2 minus sine y squared. So even if you leave your answer like this, you can leave your answer like this. That's still the answer. But if you want to make it look nicer, always, any number on the top, you can just put it on a side. So this one, you can write like this. Cosine y over 2 minus sine y squared times 2 over 2 minus sine y. Do you see? Always a number, you can just put it on a side like that. And when you multiply them together, 2 times cosine y is going to be 2 cosine of y over, I already have a square, but I'm adding one more, so it's going to be same thing as 2 minus sine y to the third power. So that's what you have here. But, oh, actually, yeah, you have to do it like this. Otherwise, because what question is asking, you have to figure out if it's a concave up or concave down. So yeah, I have to resize it first. Let me flex. It's right here. Because question is asking what's the concavity, right? But again, guys, you don't really have to do it. You can just leave it here and then you can plug in the number. So here, question is asking if it's a concave up or concave down, okay? So your y value is going to be between here. So it's going to be pi over 2 and negative pi over 2. So you cannot really put pi over 2, but let's say you're going to put something really close to pi over 2. So any number between here, it's going to be between 1 and negative 1, right? Let's see what happens. If you plug in something, let's say, something close to pi over 2. So you know this one is gonna be 0, 1, right? It cannot be, but let's say something close to something that gonna give it 0.99. So I mean, just put pi over 2. Although you cannot do it, but let's assume you can. So let's give it 2 cosine of, wait, g prime is, yeah, it's, wait a second, did I mess up somewhere? G is negative 2, shoot. Yeah. Oh, 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 oh. No, we're good. Let's see. I don't know why I put this one in the answer key, but I think this one should be good. So it's a 2 times, yeah, cosine of pi over 2. Although you cannot really put it, but I'm gonna just put it, like, just imagine this one is gonna be like pi, not quite pi over 2, but close to pi over 2, okay? 2 minus sine pi over 2, okay? See if it is a positive or negative. So pi over 2, cosine pi over 2, no matter what it is, this one is going to still positive number, but close to 0, right? So it's going to be 2 times something close to 0. So let's put 0.0001. But still, your top number is positive. Bottom number is going to be 2 minus, if you put pi over 2, it's going to be really close to 1. So let's say it's going to be 0.9999. Okay, it's not pi over 2. You just put pi over like 1.999. Okay. So it's going to be still positive or positive. Do you see these are both positive? Therefore, so it is concave up. Now, on your note that I just posted for the Google Classroom, it's not like this. Yours will look a little bit different. That's why I stopped here, because I made a mistake. This work is correct. Not I will update it maybe, because on the note that I just uploaded in the Google Classroom, if you looked at it, I put cosine here instead of sine. So I don't know why I did it, but still you get the same answer no matter what. So whatever. But this is it. So it's a concave up because it's gonna be positive. It's gonna be still positive. Even if you put something close to negative pi over 2, you will still have a like positive or positive. Okay. Now let's look at the last number, which is d. Let y equal to be a function defined by this one, which let's give it to you. That is continuous on the closed interval 2, comma 2. So it's both x value. It's not x and y. And differentiable in open interval. Okay. Use mean value theorem. We gotta use mean value theorem. So mean value theorem is first derivative is equal to slope, right? So what you have to do is f 2.1 minus f of 2 over 2.1 minus 2. You gotta put this one in. So let's do this. 2.1 minus 2 is gonna be 0.1 over. The only problem is, what's the f of 2.1 minus f of 2? So about this one, yeah, that's what we need to figure out. So let's do this one. We already know, how should I say? Well, do you see that by the mean value theorem, this interval should be between here, right? It should be between here. So it's gonna be, what's it called? What should I say? This mean value theorem, these two should be equal to this. So f 2.1 minus f2 over 0.1 is between 1 over 5, between 1 over 15. And then you really have to find the, what's it called? Differentiable, how to do this. So what I have to do is I gotta get rid of 0.1, so I'm gonna multiply by 0.1 here, here, here. So 0.1 and 0.1 will disappear like that. So I have f 2.1 minus f of 2 is, because if I multiply by 0.1, multiply by 0.1 is gonna be what? Wait a second. Yeah. It's gonna be not wait, it's not multiplied by 0.1 because you cannot really do it in this manner. So what you have to do is 0.1 is same thing as what's that called? 1 over 10 is multiplying by 10. So when you're trying to get rid of it, you gotta do the exactly same thing. So I'm gonna get rid of that. So I gotta multiply by 10 over 1, so both sides. So that's gonna be equal to what's that called? 10 over 5. And this is gonna be 10 over 15. And yeah, you just leave it like that. That's gonna be the answer. But if you wanna make it look nicer, you can simplify it like 2/3 f of 2.1 minus f of 2 equal to 10 over 2 is gonna be 2. So that is gonna be the answer. Yeah, this is the last one of the 2018 FRQ. And I believe this is gonna be the last obstacle because this one is somewhat hard to, I mean, this, if you understand this concept, it's not difficult to do it, but figuring out what you're actually doing is the most difficult part. So as long as you can do until C, I think that should be fine because this one is pretty easy to do. All right, that's about it, guys. If you have a question, just let me know. I love you guys. Bye.